Okay, so before the break, we started looking at Inkscape, which is open source alternative to Adobe Illustrator. So all the fancy drawing tools like we're used to in graphics software, but it creates scalable vector graphics, SVG files, which that's kind of our standard for the 2D vector graphics. Internal to the machine, vector graphics are vector graphics. The machine level one, if the CPU doesn't care how many dimensions we're working in, for graphics is going to be either 2 or 3. Excuse me. Either 2 or 3 dimensions. It looks the same to the machine, but the scalable vector graphics, the SVG files, that's our, I guess I should say that's the standard for the human readable way of storing and working with that. Inside they're the same, whether it's 2 or 3. If it's vector graphics, it's vector graphics. The difference is how we put it in a text file so that a human can work with it. Because scalable vector graphics with 3D data, we can do that, but it's a lot more complicated to look at and work with. So we have a different standard of how we put scalable vector graphics or 3-dimensional vector graphics into a text file, but we'll see that next week. So went to Inkscape and we started with just the Bezier curves, which we just define a bunch of points, vertexes in our drawing space, and the computer will create edges to connect all of those. So really just a connect the dots thing. We just put the dots in there, and when we get a solid shape, the computer will fill that in with the face. Is the basic idea. Take a little bit of practice, but just kind of draw the shapes you want, fill in the colors and stuff, and get, well, since this class is more about the coding thing, all the images that y'all have noticed, all the images that we do are scratch images, the working ones to test with while we wait on the nice ones from the art department. But this also works for making the final one if that's where your interest lies. 2 more buttons I wanted to point out. We can also point out if we go to our selection tool, we can still select all these shapes one at a time because they're all independent things. And right below the selection tool is this vertex tool. We can go in here and adjust our vertices one at a time. I'll do it on the head. So select the little head shape and then grab the vertex tool, and if one of the vertexes got in the wrong spot, you can just move it to a different spot. Make the chin more pointed maybe, and bring that one in so that it's not a point on the head, and make those little adjustments. That's the time-consuming part for the final graphics. Somebody in the art department has to go through and make all those fine-tuning adjustments, make sure everything in the graphics is perfect. But for our purposes here, that really is just a time matter, time and experience with it. So for our purposes, we just need a scratch image to start coding with, something to test our code with. And then the art department will send us good ones later, or we can go find free images to use or buy some nice ones. One other button I had on my list of things to point out. My notes for this section are restriction. I listed down a bunch of things to restrict myself to so that I don't get carried away, because you can see there's a lot more functionality than we talked about there. But hopefully that'll be enough to get you kind of a start. Kind of started messing around with this and seeing what the software can do and starting to get a little bit of experience with it. It takes a minute, takes some practice to get used to it. The last thing I was going to point out is under the file menu, there's also an export ping files. So once we get our image like we want, we can just export the raster graphics. There's also functionality that we can import raster graphics and turn them into SVG graphics, but there's some limitations on there. And, yeah, I have a restriction list. I should stick to my restriction list. But it can go both ways. It's just, if we have pixel data, it's kind of hard to turn that into a math equation. But it's really easy if we have a math equation, just turn that into pixel, turn that into raster graphics and just define all those pixels. Hopefully that made enough sense that you can start playing around with it and drawing pictures and seeing what you can do. Because in our video games, we want animations though, right? And well, old style Walt Disney, the Looney Tunes, back from the 30s to the 60s, the classic cartoon. Artists sat down and drew every single frame of it. Very time consuming. We can still do that. If you have a small animation, I would recommend doing that at some point if you're interested in the graphics part, because it gives you a different perspective on kind of what is involved with it and what it takes to do all that. But we have an image that is stored in terms of vectors. We talked about vectors. So actually each one of those edges is like a vector, or each one of those points is a vector. There's different ways we could look at it, but it's stored as a vector, which is a mathematical component. So the computer can do stuff with that, including manipulate it and twist it and rotate it, scale it, things like that, and generate the animations for us. So I'm going to go ahead and hit save and close out of this. I'll just minimize it and I'll close it if the video starts to get really, really jumpy. And I'm going to open up a very powerful, it's typically a 3D modeling tool, but it has the tool we need to generate that animations. So Inkscape doesn't have what we need to generate a full set of animation images. I'm going to go over to this software called Blender, open source 3D modeling software. It's been very, very popular for a very long time. My video jumpy? No, not too jumpy. After class, I will send out a video that I came across a couple weeks ago, maybe 3 weeks ago, where the title on the video, the guy calls it Bob Ross style stuff, but he builds a 3D world, and the tutorial is 18 minutes long. It doesn't take long. If you followed those links that I put in Ivy Learn and downloaded Blender 2.9 or later, it is set up to handle GIS data, which, if you're not familiar with that term, that's what satellite imagery is. So we could go grab a section from Google Earth and bring it in here to make a video game environment. It's set up to handle that in 2.9. In 2.8, we have to go in and actually install the plugin, which is just download. It's available for free on the internet. We just download it and then actually copy and paste it to where our Blender files are. So it's not that much work, but we can just grab stuff from Google Earth, and I will send out this image or this video after class of the guy that the tutorial is 18 minutes long, but it uses fractal equation mathematics to generate forests and trees and mountains and lakes, and puts together a Bob Ross thing. And with instructions, that takes like 18 minutes, but it is kind of set up for, it's a tutorial for people who are already familiar with Blender. And in our class here, I'm going to kind of go in assuming that people haven't worked with this stuff before. So kind of open something like this. We want a new just general file. And this is where our files start at. They give us a little 3D cube. I'm going to get rid of that here in a moment to work with. We have a camera as part of 3D as opposed to 2D. We need that third dimension, but then when we add that with 2D, it's obvious how we're looking at it. We're looking at it, the two-dimensional stuff straight on. With that third dimension, we also have to always define how we're looking at it. And that's what gets really confusing in the SVG graphics. And that's why it seems like there's two standard formats for scalable, or for vector graphics. Sorry, scalable vector graphics has become the standard format for 2D vector graphics. But really, that's just the human readable text file version that we go in and edit. And there's a different one for 3D that we'll look at, because the extra stuff like what angle are we looking at it from, and where is our light coming from, what angle is our light coming from, that adds a whole lot of extra that clutters up an SVG file. So we have a different format for those, which essentially the short answer on what, if you're wondering what the other format is we split those up into multiple files. We have our shapes in one file. Instead of it all in one file like the SVG, we have our shapes in one file, our viewing stuff in another file, and our lighting and material stuff in another file. So we split it up into multiple files to stick some formats together that way. We'll see that Monday. So this is kind of what it looks like, just previewing here. Up at the top, we have a bunch of tabs. And if your computer can't see all the tabs, you can bring your mouse up there and scroll. It's scrollable, which I guess is the first point on something like this. You'll notice there's a lot of buttons. We can't even see all the buttons. There's so many. There's a lot of menus hidden right now. There's a lot of stuff it can do. And I've explicitly said to see all those tabs up there, we have to put our mouse there to do that. We also have keyboard shortcuts and all of that. But our keyboard shortcuts do different things. For example, if we're here in the main viewing area and I push W, notice here it's ready to select a box, like a box. It tries to select by a box. So I bring my mouse in this area and push W, and now it's trying to select by a circle. It's using the circle select. And if I push W again, now it just gives sort of this free form of thing to select objects. Whereas if I bring my mouse over here, depending on which one of these menus I'm at over here on the right, the W key might do something different. Or the W key might not have a shortcut on some of those menus. So there's a lot that can be done here. And it takes a while to get used to it. So definitely something you want to kind of play around with. We're just going to look at some starting points. We'll start in 2D and then move up to this. I guess one that I do want to point out before we get too far is up here in these tabs. You'll see one that says scripting. This terminal should look somewhat familiar, right? We just spent a couple weeks with something in Python. So Blender is created entirely in Python. And as such, when we make new plugins or write simple scripts for our own thing, they're done in Python. Over here is the text editor. I guess the big one to note if you want to do this is import BPY, and that's the library with all the Blender stuff in it. Import BPY is what you're going to need in all your scripts for doing Blender. Not what we're doing in this class, but it seemed relevant since this is a coding class and we're going to look at 3D software. It's like, this is where we code it. Then you might immediately be thinking, okay, where do I pick up the stuff to do? Notice there's still the layout view here. So I'm going to select this square because I don't need it anyway and hit delete. And you'll see something popped up down here in the bottom. This down here in the bottom, this section shows every line as it runs through the Python interpreter. So when I clicked on that and pushed the delete key, what it did, I guess I could have left import BPY, is to get the same effect. I could have put that over here, bpy.ops.object.delete. Then those arguments and stuff. So one way to learn, a good way to learn the scripting here is just come over to the scripting tab and just do stuff with your mouse and then look at what instruction that carried out. So I wanted to add a cube. Add a cube, and see it printed up that line. vpy.ops.mesh.primitive underscore cube underscore add, and then a bunch of parameters that need filled. The size, the edit mode, the location. For a cube, we could probably get by with just the size and location. Don't need to worry about the edit mode stuff. So doing it that way shows every single parameter it takes. But that's one way to learn scripting for this particular 3D thing. And if you've only had a couple programming courses and are really new to programming, this was entirely written in Python. So that stuff, when it seems here that Python's an easy language to work with, and you start to wonder if that restricts or whatever, this is one of the most popular 3D modeling pieces of software. It was developed entirely in Python, and it will produce Hollywood quality. So it's been building for like probably over 30 years, since the 90s or something. So it does a lot, but it's a really good software. It wasn't originally in Python, that came later. But a little sidetrack from what we're doing here. So we're gonna look at 3D stuff in a couple days. For now, starting with, I'm gonna just do the 2D stuff and animate that image we drew right before the break. So we have some lights, so we'll be able to see stuff. We have a camera, so we'll be able to take pictures of that animation and export it when we're ready. We just need that image brought in here so we can work with it. So to start here, go to File. Under Import, there's an option to import scalable vector graphics, import an SVG file. Oh, and all those other files, those are our CAD, computer-aided design standards. So Blender is also compatible with AutoCAD or anything by Autodesk, or most of the other big ones. Most of the popular computer-aided design ones, Blender is fully compatible with. Yeah, lots of different things. We'll see those. We're going to import that SVG file. So click that and then just navigate to where that's at. Doesn't look like it did much. Over here, though, here's a list of all the stuff in there, and it says it's there. I'm using my scroll wheel to scroll way down. Oh, there it is. It's just really, really small, which should probably make sense. I don't see it directly listed on the screen, and it'd get confusing to pull it up, but by default, we're set to measure in meters, and we drew that picture in pixels. And meters are much, much, much bigger than pixels. So our image is going to be really small. So we're going to need to make that bigger. Also, let me bring in another cube. Because when I go to add a cube, add mesh cube, that cube over here somewhere there, it's a mesh. Notice like its icons look different than those SVG ones. So when we do this, first thing we have to do is convert those SVG paths into thumbnails. We have to convert those into a mesh, which we can do one at a time. So navigating here, the scroll wheel is in and out. Shift or click the scroll wheel kind of changes our angle. That scrolls around in 3 dimensions. Click the scroll wheel pans. So shift middle mouse button gets our panning. That'll be an important one. Middle mouse button by itself rotates around 3-dimensional space, or we can use our little thing up here in the corner that indicates where things are, spin it around 3-dimensional space that way. Or for like the case of 2D stuff, we can click and look straight on. And they're nicely labeled so we can see our green line is the y-axis, our red line is the x-axis, and the blue is the z, but we can't really, it's not showing currently from our current view. If we just click on one of those dots, like click on the Z, we're looking straight on. If we click that again, we'll be looking at the bottom. So there's a bottom and a top. The one with, if you're off center, the one with the Z is looking down from the top. So first thing we have to do is convert all these images to meshes. We can just select them, and under Object, there's an option Convert. Oh, my thumbnails are in the way. I thought that would be a good spot out of the way. So select it, then Object, Convert to Mesh. And notice the icon changed over here. And it does have to be one at a time. We can't do them all at once. So just kind of go through here and select all the objects. Select it, Object, Convert to Mesh. Select this one, Object, Convert to Mesh. Select the next one, Object, Convert that to a mesh. Make sure you're going from curve to mesh. Right, mesh from curve. And if you lose track of which ones there are, if there's a lot of curves in your image or something, this list can be nice and useful because then you can look at the icons. Okay, so those are all meshes. This one needs to be a mesh. Like that, Object, Convert to a mesh. And the next one, Object, Convert that to a mesh. Object, select it, then go to Object, Convert it to a mesh. So now I can see everything on that list is a mesh. It has the triangle icon. So now I'm going to select them. I'm going here and select all of them. And one of our big controls has to do with transforms. The scaling, and we can just push S to scale. So we push S, that'll then drag our mouse, that'll scale it up. So S and scale it up till I run out of room with my mouse again. My camera. I'll do that again. S. So I'm not going to do any coding with this size in particular, so I'm not too worried about that. That looks like a good size, I guess. So now we want to turn this into a single item here. So we bring in all those separate curves that we drew, turn them into meshes, scale it up to a good size to work with. And if we hit Control J, that's for join. So Control J as in join to connect them all into one thing. And your mouse does have to be in the viewing area to do that. So now it's just one solid shape. Oh, whoops, I forgot something. Let me undo that. So Control Z to undo. Notice our arm, everything's at the same level. So it looks like those arms are blending into the shirt. So what I like to do is grab one of those, and we have these tools over here at the left. So we come over here and bring that up just a little so that our arm, this arm is in front of the shirt, and the other one, just grab this little move arrow and drag it down a little so that they're at a different level than our thing. They're in front of or behind it. So we do, even in 2D stuff, we do end up having to use that third dimension some. So it's not like 3 dimensions are, like we haven't got to 3 dimensions yet because we still need it. I'm going to set that to look straight on. And now I'll select all of those and hit Control J as in join. and turn it into a single item. Now it's a single 3D mesh. The only vertexes left are the ones on the outside and one solid face inside of vector graphics. We can do stuff with it. And in order to animate it, it needs a skeleton. So what we do is we create these meshes, and that's essentially the skin. So once we have our skin ready, which is the appearance, the thing that shows, we give it a skeleton and then move, we can animate it by moving that skeleton, and the skin just kind of comes with the skeleton. Just like our skin kind of just moves with our skeleton. So we need to give it some sort of structure. Before we do that though, we also need our camera to be placed in the right place. If I scroll back out, right now, our camera is kind of looking at some strange 3D angle. It's not set up for 2D stuff. If we go to this view button, under view, there's an option for camera, and we can click active camera to see what the camera is looking at. So we can kind of see our character, but it's a 2D character. We're not, it's not fully 3D, even though we did have to dip in 3D a little bit. So I'm going to move that and to look better at the character. So I'm going to select it here on this list, and notice here's something we've talked about in this class before: transform data, location, rotation, and scale are transformations around the screen. So with the camera selected, this is the camera's position. So I can see where the origin is. So I'm going to start there with the camera and find a good spot. So I'm going to get 0, 0, 0 to get back to the origin. Well, actually, probably not 0, maybe 0, 0, 1. So I'm like a foot above the origin. And it's off at some angle, so I'm going to change that angle to 0, 0, 0. And what am I looking at? Okay, so it looks like I'm looking straight at the character, only I scaled it out too big. So maybe this I need to be out like 10 meters. Oh, a little more than that. Now we can adjust this until it's in the center of the frame. We'll change the camera size when we're ready to export it in about 10 minutes. So our red axis is the X one, so I'm going to move a little bit on the X axis so it looks forward, maybe 3 meters. Nope, that was too far. 1 meter. That looks about centered. And our Y one, I'll move up a meter. 2 is probably too far. What's 1.5? That'll work. And maybe bring this out to 12. Move that up a little bit more. There we go. That looks pretty centered. So just using our transform data to directly type in numbers until with the location and angle of the camera until we're looking straight at our image. So that way, when we finish animating it, we're ready to take pictures. So view, camera, and then you just click that button again. Click the active camera button again. We also could have done that by dragging around. Just drag the camera till it's in this position, pointing downward. But for something like that, I like to just bring up the view of the camera and adjust the transform data until it's the right spot. Now we can get back to our little character here. And go to the top, it looks like that camera's in the way. So another one of the buttons that I wanted to point out on my short list for things to start with is, you'll notice over in this list here where it's showing all this stuff, there's a little eyeball. So we can turn off the visibility of the camera. We know it's looking at the right thing, so we can just turn that off, and we don't have to see the camera for working with character. Throw in a little. So to move this, it needs a skeleton. And then we'll move the skeleton and the skin just kind of comes with it. Right now we just have the skin, what it looks like. If we come over here to this add button, one of the options is an armature. And yours, if you just install Blender, yours is probably just going to say single bone. I'll talk about these others when we get there. It's a very popular thing that's been around since around 2005 or so. Been in Blender for many years. So I put it in the wrong spot. So here's our bone. I put it at the origin pointing upward, which doesn't really fit our character. I'm going to rotate it. I'm going to select it, and I can push R for rotate. And from looking at the little arrows there, because I click the arrow here so I can see the main points on those things, and see that if I rotate around the x-axis, it'll be pointing in the right direction. I'll push R to rotate, which kind of goes in 3 dimensions. And then if I push X, that restricts it to only the X direction. I'm going to bend it down and so it's pointing that way. Alternatively, you can come over to the transform data and type it in, because obviously in that case, we needed to go a right angle around the x-axis. So we could have guessed that it was 90 degrees in the x-axis. Well, it was either 90 degrees or negative 90 degrees. Looks like it was positive, but either way works. And now this tool here, the move tool, we use these arrows to get that first bone into place. Somewhere around there, like a backbone. So maybe I'll angle it a little. So I'll push R to rotate, and then Z to restrict it to the Z axis, so that just rotate one axis at a time. And that looks like a good spot to start with. So we put the first bone in, and then the rest of our bones build off of that one. So I'm going to select just that bone, look straight on. So with the bone selected, the armature, you go to over here on these little menus that are the menu that's kind of in the drawing viewing area, switch to edit mode. And then we'll edit this single bone into a bunch of them. What we do is come up and click right on that little edge, the endpoint. There we go. So with that selected, in edit mode, we can push E for extrude and just extrude another bone out of there. So like a bone for the neck, extrude a bone for the head. So just like our skeletons, we'll just put a bone every place we want things to move. The arms will be a little bit tricky because we got off the Z axis. I'm going to kind of come over where adjust to an angle. And this does take practice. I've done this many, many, many times. Also on one of the degrees I got was an engineering technologies degree, which included an extensive amount of CAD work. So I've had formal education in CAD and then lots and lots and lots of practice at it. So I might be making it look extra easier than what it is. It does take a lot of practice, but we're going to have time to practice this stuff. So to get our shoulder, we can come back to the spot we want to grow from, then E to extrude a bone, bring out a shoulder about that level where that arm was pulled off in the Z direction, then extrude another one for our upper arm, extrude another one for our lower arm, and everything's movable. So right now we just need to get them enough bones and then we'll move them in position. So I'll come back to that bottom of the neck, I guess. Extrude a little bone for the shoulder, extrude one for the upper arm, and extrude a bone for the lower arm. Get them in position later. For the legs, I'll come down to the bottom of the backbone, E to extrude, and bring a bone down, or like the pelvis, I guess. E, extrude an upper leg, a lower leg, and a foot. Now we'll come back to that pelvis area, that pelvis bone or whatever. Hit E, extrude a bone for the upper leg, E, extrude a bone for the lower leg, E, extrude a bone for the foot. And now we just need to get these things in position. And it's a lot easier to do it one angle at a time. So these arm ones I can see are way off. So I'm gonna come up here and just drag this bone over with the X. We can grab the center or either endpoint to it and kind of put these where they need to be. Oh, I guess this is the elbow, isn't it? And just move that back and forth till it gets to the elbow position. And once it looks right that way, I'll turn it this way, come to some other angle, and just sort of adjust the height of it so it looks like it's the right spot for that arm. Like the skin is properly surrounding that bone, I guess is the thing. Same thing for this one. Look at this right from the bottom. This is the end of the arm, so kind of drag that over here. Again, I've had lots and lots of practice at this. So you just want to start getting practice. I was just going through the steps so that you can kind of, I guess, see what the end result's supposed to be. Put those bones in place that way, and kind of look at the side and try to get them in place. That way, that one might be a little low. And basically just position them so that it looks like the skeleton's in the right spot for the skin. If I look straight on the x-axis, tilt it slightly, looks like everything's right on the z-axis. So we can go back to looking straight on. So, looks like our skeleton's in the right position. Now we have a bunch of bones that we can move around and put in different postures, and the skin will just follow it. So that is a very, very tedious step. But did the basic idea there make sense? Our image is the skin. We add a skeleton to that skin, and now we can do stuff with the skeleton, and the skin will follow it. Does anybody have any questions about the concepts of it?
I don't believe so, no.
Okay, so I'm going to save two versions of this. I'm going to save this. It's a tedious thing, so here is a skin with bones. I'll save that one, and I'll send this out so that you have one ready to start working with if you have trouble with that step. A tedious, time-consuming thing. You'll want to get practice with it. Also save as the one we're going to continue with, character. It definitely takes practice. This seems like a good start for the into this software. 3D is the same thing. It's just we have a third dimension to deal with as well. Now we can start. We can combine those. Let me make sure that was everything in my notes. My mesh is selected. Okay, yes. So now we're ready to combine them, and the order we select things in matters. This software is very large. There's a lot of stuff we can do, and I'm gonna go back to my selection tool. Push W because I prefer the freeform selection instead of a box or a circle or telling what shape the thing we want to select is. So I like I like to hit W till I get to that freeform one. I find that makes things a lot easier. So, and just like that hitting W, our mouse has to be in our viewport area for W to do that, because if our mouse is in other places, the W might be a different keyboard shortcut. And so order matters in all over the place here, and our selection order matters. So we have to select the skin first. Oh, sorry. Over here in our mode, the first option in the menu in the viewport area, there's menus all over the place. It's currently in edit mode from adjusting that skeleton. We go back to object mode. I'm clicking in a random empty area to deselect that. We have to select the skin first, and then holding down Shift allows multiple selections. So skin, then Shift, and click on the armature or skeleton. So skin first, then skeleton. And we want to make the skeleton the parent of the skin, so that the skin follows any positions we put it in. So for that, push Control P, and there's different ways we can make it the parent. Most of the time, you want to go with automatic weights. Very, very, very smart people have spent a long time working on that. Like a number of people that do this in Hollywood practiced with Blender before they did the one like K9 for ILM, is the equivalent software that before ILM was sold to Disney, or whichever one DreamWorks is using these days. Blender has become such popular open source software, those people kind of use this for practicing with. So very, very good programmers, very smart people put a lot of this stuff together, including this automatic weighting. So it's usually right on for us. And you'll notice now this list changed, but I have to expand the armature or the skeleton in order to see the skin mesh. We should have that. If you see the mesh and have to expand that in order to see the skeleton object there, hit Control Z to undo, the normal undo keyboard shortcut, and select them in the opposite order. So now they should be tied together. So if we select the skeleton, so click on any bones, because it is just all those bones tie together to one thing. Then our menu here where we change the mode should see pose mode. So if we go to that, grab any one of these bones, and I'll push R to rotate, and you'll see it kind of comes with it. Not perfect, because that should probably be stretching the skin as well. So I separated it a bit too much, but that'll work for covering the steps. Okay, I'm not looking for perfect here, looking for just the steps so that y'all can start practicing with this. And all our bones should do that. If I come over here and push R, you see when we move that, kind of stretches out the shoe, but I'm going to ignore that for now and be like, okay, that's good enough. We can still cover the steps. Just don't want to take a very big step. Or this one, like this bone, and hit R. I guess it is a chance to adjust that. So if we go back to object mode, I think this time we select a different way. Select the skeleton, and then hold Shift and select the skin. And one of the modes that we'll see is weight paint. This tells us how much each bit of our skin is affected by a particular bone. So if you hold Shift and right-click on a bone, you'll see where the skin is stretching from that bone. And then you use this brush to kind of paint it. So blue is no effect, all the way down to red is high effect. I was just going over the steps, so I'm going to ignore that. But, Shift, click on a bone. Whoops. I left click, shift, and right click on a bone, and we'll be able to see what that bone, how much that bone's affected by that, which is just kind of choose the skeleton, then choose the skin, and then you'll see weight paint. And if you don't, you selected them in the wrong order. And then just kind of paint on the spots you want each bone to affect. There's a lot of stuff to do, but usually especially on 2D stuff, the automatic weighting is usually pretty good. I'm going to ignore that for now and just kind of go over the steps. But I guess I should, oops, I deselected it. I guess I should do something. So object, weight paint, and shift. Is it shift click? Nope, undo that. Control, nope. Alt click. Oh, that did a whole bunch. Oh, yeah, there is, we can adjust this to different levels. That adds and to that adds. I'm trying to remember which way. Select and I'm looking down here at the bottom. As I push different keys, it shows some different keyboard shortcuts. But none of those are remove. Select, zoom, no. Alt, shift alt, nope. Control alt. I can't remember how to remove it. I will add that in a comment when I send files out after class. Yeah, shift, if we just click and paint, like, so now whatever bone is going to be highly affect, this area is going to bend a lot as we move a particular bone. I'm going to skip that for now, and because I can't remember which button undoes stuff, if like this little corner. If we select our skeleton and go to pose mode and try to move the leg, I'll select this bone, hit R, and it drifted over to the other shoe a little bit. And I can't remember which button undoes it. I remember using these two fingers, so I have to hold two buttons down in order to clear something, but I'll look that up after class and not waste a bunch of time on it. For now, we just want the basic steps to kind of get, so y'all can kind of get started playing around with this. And I'll put that in the comment when I send out files later. So now that we're ready, it looks like it's close enough. You probably want to spend a little time making sure the right bones affect the right skin area. Another time-consuming thing, but then eventually you can come over to this animation tab. And there's lots of different options. We go here, it's kind of our user interface is set up. So we get a preview mode. Here's our working area again. So shift and middle click hands, kind of get that in spot. And down here is our timeline. And there's other options, so we can set up more than one animation. So we'll see how to do that before we get to Unity, because when we get to Unity, we can put the entire Blender file in there. We don't have to worry about any adjustments or anything. There's a few things we'll see later that relate to that. There's such very popular software. Most are really big game engines like Unity and Unreal will just accept the Blender file as a whole. We don't even have to export it and do any modifications. They're built into the game engines. Blender is so common. So just the steps to get started here is, once we have our skeleton as a parent to the skin, come over to the animation tab, And down here on the dope sheets, that's the traditional Hollywood name from working with film, we have to figure out how many frames we want, and then we'll set up keyframes, the important parts. So I'm going to do a 20 frame animation. So down here at the very bottom, currently it's set for 250. I'll just type a 20 in there. So now we'll have an animation 20 frames long, and then it'll just keep repeating. That's in the way, I think. Okay, that'll hopefully be out of the way. So 20 frames long, it'll keep repeating. Right now, it doesn't do anything. We haven't set that. So what I like to do, and again, there's more than one way to do it. So I'm just going to show you what I like to do, how I like to do the quick animations at least. The final draft detailed versions, those are very time consuming, take a while, and every single one seems to be unique. But for quick versions, what I like to do for, like, say, a walk animation is I'll go to frame 1 and put a keyframe there in the rest position, the spot where we drew our character. And to do that, bring your mouse up to the viewport area where we're looking at everything and push it. Make sure you're in pose mode. Make sure that's in pose mode. With your mouse in that viewport area, push A to select everything. So select all the bones. And then we push I to insert a keyframe. Say, okay, this is an important frame. Frame 1's important. So let's location, rotation, and scale. We can lock those in place. So there's this option here for to lock location, rotation, and scale for all those bones. So that's our starting point. And it's going to loop. So then what I like to do, it's a 20 frame animation. So I'll come over to frame 21, which there's a spot to type that down here. I just kind of drug it there. So that's one place, one frame after we jump back to the beginning of the loop. And then once again, with everything selected in that same spot, I'll hit I to insert a keyframe and lock the location, rotation, and scale, the transform data of all those bones. So that way our first frame and one frame after the loop goes back to the beginning are the same. So we don't end up with that duplicate or anything like that. Now we just need some stuff in between. So I'll come somewhere around a third. So 7 frames in. Let's say at 7 frames in, maybe this leg is extended forward, this leg's extended backwards, and the arms are swinging. So I'll grab maybe the upper leg here, push R to rotate it, and Z to lock it in. Because I'm looking from the Z axis, so I'm going to move that forward just a little. I'll grab this next bone down, hit R, Z, move that forward just a little. That shoe issue is still there. And then it's like he's stepping forward. And while that leg comes forward, I'll swing the other one back a little. So rotate on the Z axis, backwards a little, maybe the lower leg bone, R to rotate, Z so that it's restricted to only rotating around the Z axis, back a little bit further, and I'm just ignoring the shoe issue. Sorry about that, that would take a minute. But our key steps are we grab the bone we want to move, and then adjust the skeleton, adjust it to where it needs to be, and the skin will come with it. And then there's ways to adjust that. So when we walk, our arms usually swing too. So I'll grab the arm here, the upper arm, and hit rotate, R to rotate, just the R key. Then Z for the Z axis to restrict it, and rotate that arm back a little. The other arm's probably okay there. I'll come over here where I can select it. Maybe I'll go ahead and rotate it forward. Come back to the straight on view. And with that one selected, hit R to rotate, Z to restrict the axis and bring it forward. Okay, there's somewhere in the middle of our walk. We have the beginning and then somewhere in the middle. Once again, I'll with the mouse here in the viewport, push A to select everything, then I to insert a keyframe and lock, and then mark all of those locations, rotations, and scale data about our skeleton. So our transform data in that place. So those keyframes is like saying at frame one, we want to be in this position. And then frame 7, we're going to be in this position. And the computer will fill in everything in between. And I did about a third in so that I could do the other one as well. So this leg swung forward, so the next time I'll swing that back. I'll come about 2/3 in, like the upper leg, hit R to rotate, then Z to restrict to that axis, and bring that to something that would be like swinging backwards. While our other leg, R to rotate that, Z for the restriction, and swing that forward. And I guess swing the arms the other way. R, Z, swing this one forward, and grab that other bone back there. R, Z, swing this arm backwards a little. So probably not perfect, just going over the steps. And once the bones are in place and the skin followed along with it, with the mouse somewhere in the viewport, push A to select everything, then I to insert a keyframe and lock those things in place. So this one's, yeah, not the best walk animation, but you see it just, well, explaining the steps, it only took a few minutes there to turn that single image into an animated thing. So with a little bit of practice and patience, you'll be able to adjust that. And I saved the file of the bones in place before animating them, so I'll send that out. The final step is we need to export that. So it's like, okay, that's going to work. Really, that one wouldn't work, right? Normally we would clear out all those keyframes. So if you don't like one, you can come to a spot where there's keyframes at, like frame 13 here, right click, and you can remove the keyframes from it that way, which really, when you're not under time constraints like we are here in a classroom, that's something that's going to happen a lot. That's the practice thing. So you're going to practice this, and once you have it in place, you can come up here to our little, go back to the layout tab. So our animation's ready. We'll still play it down here. Not the best animation. Probably wouldn't go with that if we weren't in a hurry. Now we don't need to see the skeleton anymore. So the same way we just turn the camera off up here and go to that armature and just kind of hit the eyeballs so that it's not in the viewport anymore. You can see there's some strange stretching and things. That one's not perfect, but hopefully those steps make sense. Does anybody have any questions about those steps? Okay, I assume that means no questions. So I'm going to go ahead and do the last step is we want to export it. So all of these buttons over here on the right-hand side, this one here, that it's supposed to look like a printer. We'll need that in order to export stuff. So select that. And these options are for our camera. So if we come over here to this view button, view cameras, and look through the camera, we can adjust this. So maybe want the size to be 64 by 128. So click in the X and Y spots and get the new size in there. That'll work. And I think the camera could probably be zoomed in a little bit more. There's the original one. So this thing here with the square, that has our transform data. So if we select the camera, we could probably come in a little bit now. 9, maybe 8. That'll work. Excuse me for just a second. I need to get a drink. Well, we're almost finished. Think it. Yeah, I feel like I was about to cough really bad. So this square here in this menu, that gets our transform data. And then the thing that looks like a printer is our output. Okay, that'll work. Have the animation set up. Our camera looks like it's in a decent spot. Got the size. Our frames start and end. There's some other information there. The one you want to change is down here under output. Where are we going to send this animation? And then that's just navigate to the right files. I'll go to documents, under delete, make a new folder that has a character animation. And in that folder, I'm going to name the file character walk. It's not really a walk. Then I'm going to end with an underscore because there's a lot of frames to that animation. So when it exports those in, it's going to name them 001 or 0001. However many zeros it's putting in. It's going to add a digit there at the end for each frame. So just navigate to the folder where you want it to go, then start to type the file name, and it's going to add numbers at the end. So accept that name. So once you have this, the main ones to start with are the size. Make sure your frame, the number of frames is right. The output directory. And when you have all that, you'll go to render and render animation. And then this will take a second. I will be right back in just a second. I gotta get a drink while that renders. It's gonna take just a moment to render. That is better. Sorry about that. It's something you'll want to wait on. Let's go back to the screen share and see if that's coming along. Oh, it looks like it's done. Obviously, the Zoom call slows it down a little, but it'll put together, once it says frame 20 here, they go in order. So it says frame 1, frame 2, frame 3, all the way through. And that last part, the camera setup, the output stuff, that's the same in 3D. So we don't have to see that again when we do 3D data. But also 3D game engines will accept Blender files and it will do all that for us. Now if we go over here, the delete folder, here's that character animation, and there's the 20 frames of that animation, which was the steps, again, because that probably wouldn't have been kept under normal circumstances. A whole bunch of Control-Z to undo stuff, some trial and error. You move the stuff into place, move the bones, the skin follows, and you can generate your animations from a single image that way. Do the steps make sense?
Yes, I think they do.
Okay, and it does take practice. Like I said, I've had, the first time I worked with 3D vector graphics or vector graphics, the time that really springs to my mind for my first experience with vector graphics was a 3D thing in about 1996. So I've had a lot of experience just with the 3D graphics in general, but all the way back to like about 87, 88, when I first started doing stuff on computers, I thought graphics were one of the most interesting parts. So I've had a lot of experience with it. And on my engineering tech degree, there was an extensive amount of computer-aided design there. So I've had the formal training in the graphic stuff as well. But so that probably made it look extra easy. It does take practice, but hopefully those are some steps that you can run with and get some practice now. So just one more pass at the question. Does anybody have any questions about those steps? Draw your skin, and then we'll see draw a 3D skin on Monday. And then from that point, we added a skeleton and moved the skeleton into place, and the skin follows. Something to practice, and maybe start practicing with GameMaker there. And I would highly recommend see what you can put together before starting that tutorial. It's very intuitive. Those people have spent a long time putting it together, and it's been very, very popular for like 30 years, pushing 30 years now. So it's very intuitive, easy to use. So you'll probably just start clicking around in there and figure out some stuff with games. And yeah, with the images there, you're just going to want to get some practice with it. Hopefully, the main point in that is that it's not raster graphics. It's not pixel by pixel data about the color. It's actually an equation that represents the image. And that gives us so much more control over what those images can do. So obviously, if we have the equation, we can manipulate that equation in our code or in software like what we just saw there. Any questions about today's stuff?
Hey, have they fixed Internet Explorer in the classroom yet?
Oh, yes. For those in the 6 o'clock class, yes, those are up to date now. What happened is half the computers.
I'm just curious because
I guess this is relevant. So if you're there in the computer lab at school 158 or 162, please do not shut down the machines at the end of the night because the updates run at 1 a.m. So whenever an adjustment needs done, it happens at 1 a.m. So if that computer is turned off, it doesn't get the update. So that's why there were some things that worked on the machines and some things weren't, because some of them got shut down and missed an important update on the software for the semester.
okay, because even when I tried to go to that website on Google Chrome, it wouldn't let me.
Oh, you have to go there from the school's lab. But if you're going to be in the classroom tonight, we'll look at that this evening. We're going to have lots of lab time in that class as well.
Okay.
Any other questions about the graphics and getting started in GameMaker?
No.
I guess it's about an hour and 20 minutes to mess around with it on our scheduled time. So as always, I will be sitting here until 4:50, ready to hop back on a Zoom call. But I don't get the video until this Zoom call ends. So do need to log off here so that we can get the video and get that up there if you want to spend that time working on the lab. Please use that time productively. You can ask me questions anytime. That is when the next hour and 20 minutes is when I'm going to be sitting right here waiting for my phone. Text messages and IB Learn messages make noise on my phone, and I can be back on a Zoom call in a split second. Otherwise, I will see you all on Monday, and we will extend that up to 3D vector graphics, which is an extension of what we did. Y'all have a great weekend.
All right. I'll see you, Chris.
Hey, you have a good weekend.